Let's quickly start with today's session, but before let's quickly revise what you have done till the last class and then we'll continue for that. Okay. A quick update on where we are currently in our syllabus. We have already talked about time and space complexity. We have covered arrays as data structure. We have covered the introduction to programming and the basic fundamentals of programming in general. We talked about linear search, binary search, prefix sum, and questions related to that. Okay. Sliding window concept we have covered. Questions are pending. 2 pointers we have already covered the question on top of it. What we are doing as of now is we are doing some advanced algorithm based questions. So we talked about some approach for, let's say, to some array of replacement, finding the next getter element, then majority element, and wiggle sort. Today we'll be continuing the same. We'll be talking about decompress RLE, which is an interesting algorithm for compression, which is pretty much used in all the major products that you have gone through. And then we'll talk about product of array except self and some rotate array kind of questions. Once we are done with that, then we'll move on to the next data structure. That way will be covered with data structure of array and algorithm based upon array as well. Okay. Quick revision what you have done yesterday. We did a couple of good questions starting with lead code 169, which is majority element. So the question says you're given an array of size n, return the majority element. The definition of majority element is something which appears more than n by 2 times. Okay. And the test case are generated such that the majority element would always exist. Okay. So let's have understanding of the question. For example, if I talk about this test case, it has 8 values and 1 appears 4 times. So this is not a valid test case because technically this whatever, either it's 1 or some other element, it should exist more than 4. So this is invalid test case. And coming to the part, can there be more than one majority element? The answer is no. There can be only one majority element if it exists. So to this question, there are multiple solutions. If I talk about approach wise, there are 4 solutions. In terms of total solution, there are 5 solutions. Brute force, using map, sorting, partial sorting, and bare-more. Bare-more is the most important one, O(n) time, O(n) space. Now coming to the brute force solution, what exactly is that solution? We talked about all the solution in detail. The solution is for each and every element, you calculate its frequency, you based upon 2 nested loops. For whatever element, and there's going to be only one element like that, if frequency becomes greater than n by 2, you return that particular element. Time comes to big of n square, space comes to big of 1. Then we talked about map-based approach. What's the intuition behind using a map-based approach? We know that we are talking about the frequency here. So definitely whenever the frequency part comes in, map can be definitely one of the solution. So we create a map of element and frequency. Wherever frequency becomes greater than n by 2, that particular key would become the answer. Time comes to big of n, space remains big of n. We talked about the code, we create a map. In that map specifically, I'm checking. One optimization that I've done here is, or I've shown you here is, instead of creating a map first and then iterating through the map, what you can do is you can do both the things at the same time. While you are populating the map, you don't need to wait till you complete the map and then you go over the map values to compare whichever value is frequency greater than n by 2. While you're constructing the map at that moment itself, you can get it. So that way you don't have to go through all the elements. This in worst case will go to big of n. But if you find a, let's say, even by n by 2, the whatever the first element is there, it's available. Even before going till the n part, or even if going through all the values in that array, you will still get your answer here. So worst case, it will hit big of n, and the best case will hit definitely big of n by 2. Okay. So this is a much better solution. That's why defeat 100% of the summation. Time comes to big of n, space comes to big of n, because we use the map here. Third approach is based upon sorting. What do you mean by sorting based approach? The sorting based approach is, or what's the intuition behind sorting is? The intuition behind sorting is, once I sort the list of values, all the elements which are same, they will be together. Now, if we claim that there is a majority element, means there would be an element which consists of more than 50%. I showed by the diagram, irrespective whether it lies in the first half or it lies in the second half, at index n by 2, there will always be an overlap. So what do I need to do? I just need to sort the value at index n by 2, it will be a majority element. Okay, it's valid in the case frequency of majority element is greater than n by 2. So we just sort 2 lines of code, we sort it and we return n by 2. Time complexity n log n, space complexity big of 1. Then we talked about partial sorting. What is partial sorting? Something similar. After sorting index n by 2, it should be majority element. So instead of sorting the entire element, I can just sort the n by 2 part of it. Okay. Then we talked about the most optimized solution, which is bare-more algorithm solution. We talked about the research paper. We talked about how does this approach was built. See, this works only in the case where the majority element is guaranteed to exist. Okay, let's be clear on that. And the definition of majority element is greater than 50%. So what does this trick say? So what does this research paper altogether says? The research paper says just about 2 conditions. If the count becomes 0, you directly increment the count. Else, there are 2 cases. If the count is non-zero, there are 2 cases. If the next element is the same as the current element, you increment the count. If the next element is different than the current element, you decrement the count. That's it. So if we go via code, and we did go through the diagram as well, what we do is we define some majority element equal to nums equal to 0, starting with that. 2 conditions. If condition, else condition. If count becomes 0, increment the count, update the majority element. Else condition, two different parts. If it is the same, you increment the count, otherwise you decrement the count, and then you return your majority element. Time complexity big of n, space complexity big of 1. This is the most optimized solution. Okay. We talked about Bear, Murray, Pigeonhole, Morris traversal, bit manipulation, randomization. These are some of the common algorithms, important algorithms from the interview perspective, which can also be asked. Okay. Then move to a really good question, which is question number 4, lead code 280, wiggle sort. It's a premium question. So we talked about the alternative free website, which is on lint code. What does the question says? You're given integer array nums. You need to reorder it such that it becomes in a wiggle order. So I told you about what do you mean by wiggle. There are two parts of wiggle. So wiggle in general means low, high, low, high, low, high kind of values. Just like you can think of stock trading, there are wiggle charts there. In this case, there can be two different categories of wiggle. It can be a soft wiggle, it can be a hard wiggle. Soft wiggle means it doesn't care about the amplitude. It can be lowest and highest, or it cannot be lowest and highest. Okay. But when we talk about hard wiggle, we specifically talk about smallest, largest, second largest, third smallest, third largest. So it's going to be a decreasing amplitude. I explained that via the graph as well. Okay. So how do we solve this question? This question didn't mention about soft wiggle or hard wiggle in general. They just talked about wiggle. But I told you based upon so that you can have understanding of soft wiggle and hard wiggle as well. Now coming to the solution part, they said any wiggle is fine. They will accept any wiggle solution. So there can be multiple solutions to one problem statement. What are the solutions apart of it? See, the first and very important intuition is sorting. Why and how did we get the intuition behind sorting? After sorting, I know I'll get the pattern less than equal to, less than equal to, less than equal to, and less than equal to. What I need a pattern is just a tweaking part of it, less than, greater than, less than, greater than. So what I have to do? Odd index, I just need it to be higher, so I can just swap the values. And that's something that we observed when we look at the pattern here. Value at the odd index is always higher. Okay. So coming back to it, I can sort the array, I can increase the index by 2, and I can just swap the values. I can talk about some edge cases. If array length is 1, there is no wiggle. If array length is 2, you just need to check first element should be less than the second one. So this is what we do. We do arrays.sort and we just swap the values. Time comes to big of n log n plus big of n by 2. Space comp remains big of 1. Now, n log n is fine. It's not a bad solution. It's not like as bad as big of n square, but n log n is still something which is not very optimized. Can we think of any solution which works in less than big of n log n? The answer is yes. We can do the solution without even using sorting also. Approach remains the same. The only pattern is if the number at odd index, it has to be the peak element. So what do? We talk about two conditions. If index is odd or if index is even. If index is odd, I just want the odd element to be higher. So odd will be greater than equal to even. If index is even, then I want that element to be again higher. So even should be less than equal to odd here. Okay. So we put this two condition. If condition, we just make sure that odd element remains at the peak. Else condition, again, we make sure odd element remains at the peak. And this is the code for swap because Java by default does not have a code for swap. Time comes to big of n, space comes to big of 1. This is the most optimized solution. Then I gave you guys wiggle sort 2 as a homework, which is lint code 507. Before we go to that, everybody crystal clear with the revision? Everybody crystal clear with the revision? Quickly in the chat. Okay. If you guys are clear with the revision, now coming back to this, how many of you have tried lit wiggle sort 2? The way we are applying logic, if all elements are same, that will be a necessary step. We cannot reduce that. If all elements are same, that will be a necessary step. That's an edge case, right? If all elements become same, that's just an necessary step, but not all the test cases will have that. Okay. For wiggle sort 2, how to deal with scenario where 3 adjacent elements are same number? You have to reorder it, right? So there's no point of adjacent element. It's just the way how you want to reorder them. Okay. See, the whole purpose of this question, wiggle sort 1, wiggle sort 2, or any of this variation is you can change the places of the values. So when you say 3 adjacent elements, you can shift around the values. Okay. Coming back to it, how many of you solved wiggle sort 2? Do you guys need my input? Are you guys good? Just let me know. Accordingly, I'll take up the question. Come on, guys, quick in the chat. If you guys have solved it, I'll skip it. If you guys have not solved it, I can take it. Whatever works for you. Guys, yes or no is not helpful to me. Should we take it in the class or should we not take it? Let me know. Okay. Shift to adjacent element will still be same, right? Depends how you shift it, but let's take this question because looks like, okay, let's start with this. I'll find the appropriate lead code version as well. All right, let's go to wiggle sort here. Let me take it here. Let me bring it back. What is it? Okay, this is wiggle sort 1. Let's go to wiggle sort 2. Yep, we have wiggle sort 2. Looks like wiggle sort 2 is not. Okay, wiggle sort 2 does not look like a premium question. Fine, no worries. Okay, let me come back to it. Cool, guys. Wiggle sort 2 is available on LeetCode for free. So that's something you can actually try for. Solve what test cases are failing. Cool, no worries. All right, let's go to LeetCode 324. I believe all of you guys can see my Chrome screen. Let's talk about this, then we'll take it from there. Let's take this question first. I'll copy this. This is LeetCode 324, wiggle sort 2. If we talk about the stats, 499 point, almost 500K submissions and 35.4% is play. So almost 1/3 of the submission, which got accepted. Nice. If we talk about companies which have asked this question, some really good companies, product base, have asked these questions. Anyways, the question says, given an array nums, reorder it in such that nums of 0 is less than nums of 1, greater than nums of 2, less than nums of 3. Basically, this is the same question, just that less than equal to condition is now changed to less than greater than. You may assume the input array always has a valid answer. So they have given an example. 151164, it becomes 161514. This is example of a hard wiggle. And 141516, this is example of a soft wiggle. Both are acceptable solution. Then you have 132231, so it becomes 231312. Okay, greater, higher, smaller, higher, that kind of thing that we need. Length is up to 10 to the power 4, values are up to 0 to 5000, which is fine. It is granted there will be answer for given input nums. Okay, then they come up with a follow-up. Can we solve it in O and time and in place solution with big of an extra space? Cool, let's spend time on it. Although there is one solution which we are yet to go, randomization and stuff, but other solutions we can definitely talk about. So let's bring this guy here. And prior to that, which was the number of this question? 4, right? Let's go to question 5. This is question 5, LeetCode 324, wiggle sort 2. This is the LeetCode version. There you go. Okay, looks good. What else do we need? We need to add the function that we have to complete. Function would pretty much remain the same. Let me take this part. This is the function that you'll be completing. Okay, it's a void because you need to reorder. So it's just a void that you're returning. You don't returning an array or anything. All right, before I move forward, anybody has any doubt in the question? The question is pretty much the same as wiggle sort 1. So there's nothing much to talk about here. Anybody has doubt in the question, let me know. Anything which is not clear, anything which needs my input, let me know. Most of questions have been taken around the number, not the string. Any specific reason? Because we have not covered strings yet. Once we cover string, then we'll take for the strings. Okay. All right, guys. Any doubt in the question of wiggle sort 2? Any doubt in terms of requirements? Anything which is not clear? It's the same question as wiggle sort 1, just one difference. Instead of less than equal to, you need to reorder with completely less than and greater than. Okay. Come on, guys. So adjacent elements should not be together. That's the one thing that we're trying to fix here. Come on, guys, quick in the chat. Everybody crystal clear? Any doubts? Any questions? Okay. I'll take that as no. I think the question is clear to you. Those who have not solved it, because there's some of the comments which have not solved it, I'll give you a couple of minutes. Please do not take too much time because we have to solve this question and I have planned other 2 questions for this class. So I'm giving the question link here on the LeetCode. It's not the premium one, so you can directly access and solve it on LeetCode. And this is the function that you have to complete. Okay. You guys know the drill. Directly go on the lead code, start submitting your solution. Once you guys are done, just share the submission link with me. Do not message to everyone, change your message directly to me. We should not take more than 2 to 3 minutes for this one, and then we should head to the discussion. Okay. All right, guys. I did that. You don't need anything else from my end. If you do, please let me know now. Okay. It's completely fine if you cannot come up with own time, own space, whatever the most optimized that you think you can come up. Let's start with that, and then we'll talk about optimization. Okay. The constraints are not that big that even constraints are so small that even your brute force will pass all the test case. Okay. All right, guys, all up to you now. Please change your message directly to me. Do not message to everyone, and then we'll go for discussion. Your time starts now. All right, guys, enough time. We should not be spending too much time on this. We have other questions to cover as well. Okay. Cool. How many of you have solved this question? I can see 6 submissions as of now. Anybody else who has solved this question already? You can message to everyone now. Completely fine. Okay. Cool, guys. Shall we go to discuss? Does anyone need more time? Let me know. I don't want to spend too much time on this question because technically I gave this question as homework yesterday. Are we good to discuss? Cool. Let's discuss the solution. Okay. See, this is an interesting question. Interesting question in the sense there is a way we can simply solve this question. There is not too much complications around it. But the complications comes when you have to follow this constraint, O n time, O n space. Overall, this question has 3 solutions. If you talk about on a higher overview level, first question is very intuitive. You can come up with that solution. Second solution is an optimized way of that. Again, not very useful. Time complexity is same. And then third solution is something which will require you to know further algorithms, especially related to sorting. Okay. And that's the solution which can get you in O n time and O n space. Okay. That is the reason this question is marked as hard in the lead code side. Let's talk about the approach first. We know a couple of things. Let's take this one. This input will tell us everything. If my input is given as this output 161514, this is hard wiggle. Okay. And this output 141516. Technically, this is also hard wiggle, but this soft wiggle. It's a reverse hard wiggle, you can say. Okay. More or less, the question is asking you to not put the duplicate elements together, however it is. Let me give a definition here. When we say hard wiggle, we are referring about smallest, largest, second smallest, second largest, third smallest, third largest, so on and so forth. Okay. This is the definition of hard wiggle. And when we talk about soft wiggle, that means does not necessarily need to be like this. Okay. It just needs small, large, small, large, and so on and so forth. That's the definition we talked about soft and hard wiggle. Now, what about the code for this one, or what about the solution for this one? See, the most intuitive solution that you can come up with any kind of wiggle that you have to make is sorting. Why sorting? What's the intuition behind sorting? Let's come back to where we discussed in the wiggle sort one. Come back here. Or index will remain the same. Till this part, I can actually just copy paste it. This guy. What's the intuition behind sorting? The intuition behind sorting is pattern will become this, less than, equal to, or whatever that is, less than, and less than. What I need is less than, greater than, and so on and so forth. How do we do about it? See, odd index will be at the higher value, but instead of swapping it, I don't need to swap the values or do anything here. I need to do something else here. What do you mean by something else here? At odd indices, I need the larger value. At even indices, I need the smaller values. So this is what I need. Odd indices, I need the larger values. Even indices, I need the smaller values. Everyone is crystal clear with this. Come on, guys, quick in the chat. All I need for this kind of a pattern, at odd index, you put the large values, at even index, you put the small values. Now, how sorting is going to actually help me? Once I sort the array, I know at the end of the array, like on the last element, the values are going to be larger. All agree? At the end, at the last, the values are going to be larger. All agree with that, right? And once we go from the beginning, the values are going to be smaller. So what I can do, after sorting, values would be larger to smaller from right to left or end to beginning, whatever you want to say. So what we can do, travel right to left, number one, put values into odd indices, which will be larger values, and then put values into even indices, which is smaller values. Simple. That will do the job. Okay. Let's quickly write down the code for it and let's validate that whether it works or not. This will count as approach rather than the code. Okay. Let's go to lead code. Let's try to implement that. We are back on lead code. Let's see. If I go to Java, yep, I've pretty much submitted that. But let me see. Hardware is fine. This is fine. I'll just comment this guide meantime. Okay, should be good. What else? This is fine. This should be fine as well. Okay, cool. Coming back to the code, this will help us understand what I just approached. See, what is my approach? Let me compile this real quick. One moment, I'll explain this. Yep, we are good with the comments. Now come back here. See, what I'm doing here is, number one, I'm sorting the array. Once I've sorted the array, only thing that I'm doing is I'm traveling from I equal to 1, nums.length, I plus equal to 2. At nums of I, remember, I need to reorder the same array. So at nums of I, I'm making value index minus minus. What is value here? Value of just create a copy of an array which I have sorted it. Because if you sort the original array, how are you going to make sure that you get copy pasting the values at the right place? So that's why I created a copy of the original array, which I sorted. And from the sorted list of values from the duplicate array or a new array, that is where I'm reordering the values here. Okay. So after sorting, the last values are largest. So what I do is I start from index minus minus. Where is my index pointing? My index is pointing to n minus 1. So nums of I, which is my original array. Listen to my words carefully. Nums of I, which is my original array. I am going from left to right. In that left to right, starting from I equal to 1, I plus equal to 2 means I am covering the odd indices first. So in the odd indices, I am putting value index minus minus. Index is going from n minus 1 in the copied array, which is the sorted array now. So this value will put all the large values inside my odd indices. All agree with this? This piece of code will put all the large values in my odd indices, in my original array. Then I'm going to the even indices. I start from 0, I do I plus equal to 2. Now I'm covering the even indices. I am traveling from right to left in a sorted array. If I already covered the large values, now what I'm left with the smaller values. So in the smaller values, now I am putting in the even indices. This part clear to all? Okay. That's exactly what I'm doing in the code, nothing else. Okay. If you compile for one test case, let's take for 151164. This code is what is giving you the hard wiggle because you take the smallest and largest, smallest and the largest, and so on and so forth. Same if I go for test case 2, 231312, this is how it is going to work. Smallest, largest, and so on and so forth. Okay. All right, guys. Now let me know if anybody has any questions about this approach or code. Now, time complexity will not be big of n because we are sorting there at line number 18. So it's n log n. Please explain me once that I did not. One moment, guys. Here space will be big of n. Yes, we create an extra array. That's why the space will be big of n. Correct. Explain me once why that I did not understand why two for loops. Okay. Can we reduce the space complete to big of n? See, the reason I created a space extra array is because I wanted to have the duplicate, because I do not want, to your answer, yes, we can have the space complete big of n, time constant big of n. There's a separate approach for this. But considering with this approach of sorting, it's mandatory to have another array so that you can have the list of sorted values and you can reorder it in the original array. Okay. One way of not creating an additional array is a second way, which is optimized version of this with space complete big of n, is that you can use count sort or bucket sort. In count and bucket sort, you need to have a range of values and based upon the constraint. Technically, that's not a solution. That's just a play around because we know the range of values we are going to deal with. So without creating an extra space, we can still do the count sort or bucket sort that will give the space count a big of one. This is the second approach I'm talking about here. Okay. Anyways, to your part, why did we have two loops? Let me tell you why did we have two loops. See, in the first loop, I'm taking care of the odd indices. And in the second loop, I'm taking care of the even indices. If you combine both of them, my time constant will still remain big of n. Once I cover all the even values, once I cover all the odd values, overall I cover all the values. So this complexity is big of n, no doubt. This complexity is n log n. This guy here. But this is big of n. So my total overall complexity will become big of n log n, and space count will become big of n. Okay. Cool, guys. Everybody crystal clear with this? Let me know. Approach wise, code wise, if anybody needs a dry run, I can do a dry run. Else we can move on to next question. Okay, cool. Let's compile the code. Let's try to submit it. It should pass all test cases, but again, it will not be defeating 100% because complexity is not the most optimized part. But if you look at the complexity, okay, the length is bit, but anyways, we know the complexity is n log n and space count is big of n for this code. So we don't need lead code to tell us, but we know the complexity. Now, this is not the most optimized solution. There is a solution which will work in ON time, and ideally speaking, it will work not in the worst case and big of n time. Space compty would remain big of n, but not in the worst case, it will remain big of n. That solution is randomized quicksort. But before we go to randomized quicksort, we have to go through all the parts of quicksort in general or sorting in general. Okay. So this is the solution. If you want, I can share the submission link, but there's no point of doing it because I have not covered that yet. Okay. It's a part of quick select and an advanced level of quick sort, which we call as quick select or randomized quick sort. That can work in best case as well as the average case in time comes to big of n, space comes to big of 1. Okay. That is what they have expected in the follow-up part. But anyways, even if you this code in the interview, that is also acceptable. Until unless interview specific looking for on time open space, this code is pretty much acceptable with this constraints. Okay. So as of now, I'll stick to this one. And once we cover the quick sort, then we'll come back to this. So let's go here. Let's come back here. There you go. All right, guys. All looks good on this end. Let's quickly cover next question that we have for today. Okay. This was question number 5. Let's quickly move on to question number 6, which is, I guess, kids with greatest number of candies, which if I'm not wrong, yeah, this guy. Let's quickly do that. Then we'll go for decompress RLE. Okay. Till it opens in the meantime, let me get the link and the question that we can discuss. But here, let's come back here. Cool. It's a pretty straightforward question, so I don't expect more than 5 to 10 minutes overall for this submission. So let's do it real quick, and then we can move on to next. What does this problem statement says? There will be something called decompress RLE, which, oh yeah, there is decompress RLE. Cool. I'll bring this question here. Anyways, coming back to this. This is lead code 1431. Name of the question is kids with greatest number of candies. Let's quickly go through the question. Fairly straightforward question, not spending too much time on it. You can see 1.4 million submission, almost 90% got accepted. So fairly straightforward question. What does the question say? The question says there are n kids with the candies You are given an integer array candies where each candies of I represent the number of candies the ith kid has, and an integer extra candies denoting the number of extra candies that you have. You need to return a Boolean array result of length n where result of I is true if after giving the ith kid all the extra candies. This line is important, all the extra candies. They will have the greatest number of candies among all the kids or false otherwise. Note that the multiple kids have the greatest number of candies. Fairly straightforward question. They have given very detailed input output to understand that. If you look at the first test case, 2, 3, 5, 1, 3, extra candies is 3. All you have to do is you have to give each kid all the extra candies. You don't have to talk about minimum, maximum, or the pivot point where you have to give to become maximum. None of those variations. You have to give all the extra candies, and then you have to compare if after giving all the extra candies, do they have the maximum number of candies? So basically, in this array, if I add this number to each element one by one, does it become the maximum in the array? If it does, you return true, otherwise return false. You need to return a Boolean array. So let's go one by one. 2, 3, 5, 1, 3. If I add 2 plus 3, if I give all the extra candies to this, output will become 5. So this array will become 5, 3, 5, 1, 3. Will it become the maximum in the array? Yes or no? Will it become the maximum in the array? It will. So output becomes true. Coming to next element, 3. If I give all the 3 candies, 3 plus 3 will become 6. Now 6, the array will become 2, 6, 5, 1, 3. This will become maximum. So output becomes true. For 5, 5 is already maximum, and then you add something to it, so it will always be maximum. Output becomes true. For 1, if I add 1 plus 3, that will become 4. Not this guy. If I add 1 plus 3, that will become 4. 4, after that, the array will become 2, 3, 5, 4, 3. 4 will not be the maximum. In that case, what will happen? The output will be false. In 3, if I add, we have already taken care for the test case of 3, so output will be 6, so it will be output is true. So if you look at the output, my output will look like true, 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 false, and true. Everybody crystal clear with the question. The problem is this problem statement is not that complicated. That's why I don't spend too much time on it. It's a fairly straightforward question on how you implement it. Okay. They're given other test cases also. If you want to talk about, feel free to go ahead. N is the candy's length. And candy's length is starting from at least minimum of 2 elements and going till 100. And the candies value start from 1 to 100. Extra candies is 1 to 50. Constraints are fairly small. Okay. Let's take this problem statement real quick. Come back here. Print it. Example 1. Explanation. Example 2. Explanation. Example 3. Constraints, so on and so forth. This is 1431. And what do we need? We need the function that we have to complete. One moment. Okay, cool. If it is in the assignment, that should be pretty straightforward then. You guys can quickly share that. First thing first, I'll cover the understanding and then we can move to the solution part of it. What is the understanding of this problem statement? The understanding is this. And that's it. Then we can talk about the solution. Cool. Yeah, if it is covered as part of assessments or assignment, let's quickly give the solution, those who have already solved it. Okay, it actually will save us time. But anyways, those who have not solved it or those who have not completed the whole assignment or assessment, let's quickly finish or give them a chance to do it now. Any doubt in the problem statement? Anything which is not clear as part of problem statement? Cool. Straightforward question. Let's quickly implement it. From my end, I have to give you the lead code link, which is right here in your chat now. And there goes the function that you have to complete. Those who have already completed, just share the submission link to me. Okay. All right, guys, let's quickly finish in next 5 minutes and then we can move on to the next important questions. All right, guys. Just share your submission link. You guys know the drill. Change your message directly to me. Do not message to everyone. Once you guys are done, please let me know. We can go ahead for discussion. Your time starts now. Okay, cool. Let's discuss this. It's a pretty straightforward question, so I don't want to spend too much time on it. We have other important questions that we would like to take time on. Okay. All right. The approach is pretty straightforward. I don't think I need to tell. Majority of you already solved this question anyways. All you need to do is find the maximum in an array, and then for each kid, this is what I need to check. If that array of I plus all the extra candies, if that becomes greater than equal to the maximum in the array, then I return true, or I set the value as true, else I return false. Everybody is clear with this? That's fine. Everybody is clear with this? That is the approach. First, you find the maximum in the array. Then for each kid, you need to check if I give all the extra candies and it is greater than equal to max, because there can be multiple elements which can be maximum, I return true, otherwise I return false. Time complexity of this approach is big of n. Space complexity of this approach is big of 1. Okay. Remember, candies greater than max is incorrect condition because there can be multiple maximum elements. Candy is greater than equal to max. This is the correct condition. Okay. Let's quickly move to the code part and then we'll talk about more in the code. So let's come back with this. Let's change our language to Java. Let's quickly go through the code part here. I think approach I have not written here, but anyways, let me write down the approach real quick. There you go. There goes the approach. Cool. What are we doing here exactly? What we are doing is, number one, first I create my length as candidates.length, and this I have to return a list of boolean. So if I create that list of boolean, that will not count towards extra space. This still remains my space as big of 1. I define max equal to 0 because I don't know what's the value. So what I can do is here, I can define candy in candies. I find the maximum element. This code becomes big of n. Then what I'm doing, I'm just checking if candy plus extra candies become greater than equal to max. So the output will be either a true or a false. That I'm updating in my list of array. And then I return the answer. Pretty much that's the 2 line of code that we have to go through. Then I return my answer, time comes to big of n, space comes to big of 1. Look at the code. Let me know anybody has any doubts, any questions. If we create an array with fixed size, will that consider extra space? We don't return in function. No. If we create an array of that size of n, that will be counted as big of n. Okay, but if it's a fixed space, let's say 10, 15, 20, that is not counted towards extra space. Okay. All right, guys. Everybody clear with the code? Anybody has any doubts, questions? Cool. Compilation looks good. Let's quickly submit it. Submission works fine. We already know it will defeat all the submission. Time const remains big of n. Space compty would be big of 1 because we are using it. Space compty is big of 1. Okay, this is the most optimal solution. Somebody mentioned that lead code is presenting space as big of n. To my code, it's presenting still big of 1. Maybe check something that you have done in your code. That might be helpful. Okay. All right, guys. Let me take this piece of code. Let's come back here. This is the most optimized solution. Okay. All righty. This should be fine. Okay. Any more questions? List of boolean, new array list of boolean. Then max candies. I think you did not define the size here. The way that you're defining, I'm very specifically defined. I'm taking a length of length n. That's why taking space compty is big of 1 here. Okay. Just try adding the variable length here and then tell me what's the space compty showing. Cool. All right, guys. Everybody crystal clear now? Everybody crystal clear? This question looks good. Time, space, complexity, code, approach, everything. Come on, guys, quick in the chat, and then we can move on to the next question. Okay. If everything is good, let's quickly move on to the next question. This was kind of an easy question, considering the level of problems we are discussing now. This is a very easy question. We'll go back to our level of question that we were doing, medium to hard. Okay. Question number 7 is important. Let's talk about that a bit. And before I even go to the question specifically, let's talk about the algorithm a bit. So I'll cover a bit about run length encoding. Okay. So what run length encoding is, it usually given a character and its corresponding frequency. For example, if I talk about AA, BB, CCC, if I have to encode this, or basically if I have to compress this, I'll write A2, B2, and C3. And if I do the other way around, so this is what you call as encoding, basically compression. If I do the other way around, for example, if I give you A2, B3, C1, then this will correspond to AA, triple B, 1C. That is what you call as decoding or decompression. Decompression slash compression. Where is run length coding exactly used? Run length coding is a very useful algorithm. It is used in a lot of places in terms of compression. A simple example of how these are compressed or how these values are compressed, if I talk about use cases in general, any media that you upload, let's say uploaded on Instagram slash Facebook slash any social media, even WhatsApp also. Let's say that you have 5 MB of pic on your phone and you upload to Instagram server. Do you think it will still have 5 MB on the Instagram server? Think logically. It's actually part of design, but I'm covering a bit in the DSA part also. So before you move to the system design, you understand this. Understand from an engineering standpoint. Engineering standpoint in the sense, Instagram has more than 2 billion active users. Okay. In that 2 billion active users, even if you imagine total number of pictures are posted, let's say 5 per account, that gives 10 billion pictures posted. If you start taking the exact same quality size, I mean, I say quality, we are not distorting about the quality, with minimum compression in the quality perspective, but maximum compression in the size perspective. If you start taking and assuming a size of 5 to 10 MB on 10 billion pictures, you will run out of so many storage devices. Okay. And then you'll be paying very hefty bills in terms of your storage devices because storage is expensive, right? Now, that's why the concept of compression comes in. Not just of Instagram. I took an example of Instagram. In general, anything that you upload your data to, apart from Google Drive and stuff, because they maintain the same size. That's why they have limited 15 GB of free. After that, you have to pay for it. Any particular website that you're uploading your content to, they will try to decompress it. Why would they try to compress it first? They would try to compress it so they can use it in a smaller format. So that 5 MB that you're seeing in your phone, actually in Instagram server, it will not be more than 200 KB. The compression quality will be so good. The quality would remain pretty much the same. The compression size will become so less that it will not have, or it will have minimum impact on the quality of the image. This is what you call as compression. And run length encoding is one of the compression algorithms. It's a very useful, very popular one. That is where it is used here. This part clear to all? Come on, guys, quick in the chat. Just making you aware what is run length encoding in general, where it is used. We'll discuss more once we go to the system design and all of that part, but just for your understanding, you should know this. Okay. Now coming back to the lead code question that we have. So let's quickly take the lead code screen. Let's come back to our problem statement. This is the decompress RLE. All right, let's understand the problem statement first. The problem statement says decompress RLE, not compress, decompress RLE. We are given a list nums of integers representing a list compressed with the run length encoding. So we already have a list of compressed values. Consider each adjacent pairs of element as frequency comma value equal to nums into 2 into I, nums comma t into I plus 1 with I greater than equal to 0. For each such pair, there are frequency elements with value concatenated in a sublist. Concatenate all the sublists from left to right to generate the decompressed list. Now, this is something important. I don't have to do any compression. I'm already given a compressed list. I just need to decompress it and give the decompressed list. Let's try to understand better with an example. The pair is given as frequency comma value. This is important. What's the frequency? What's the value that is given to me? So if I take about the first pair, there are only two pairs, 1, 2, and 3, 4. If I take the first pair 1, comma 2, 1 is the frequency, 2 is the value. Everybody clear with this? If I talk about 1, 2, 1 is the frequency, 2 is the value. Quick in the chat, guys. Okay. If I talk about second pair, 3, comma 4, 3 is the frequency, 4 is the value. This part clear to all? Okay. Now coming back to the first one. If 1 is the frequency, 2 is the value, I need to decompress it. Means it's already in a compressed form, I need to basically enlarge it or decompress it. If I do decompress it, my output will become 2. There is 2 with the frequency 1. If I decompress this, 4 is the value with the frequency 3, it will become like this. What do I need to do? I need to decompress everything and then return the answer. So my output will become 2444. I just need to concatenate all these values. Everybody is still clear with this? Come on, guys, quick in the chat. Any doubt, any question, anything which is not clear, please let me know. Good. Okay. Let's talk about the constant. Constant is given as minimum length equal to 2. Why the minimum length is 2? Why the minimum length of the array is 2? Why it is not 1? Come on, guys, think about it. Correct. It's a frequency comma value. At least one pair will exist. Nums dot length will be obviously even value. That's why the modulus 2 is 0 and values between 1 to 100, which is fine. Okay. Cool. Let's take this problem statement. Let's start solving a bit. Then we'll talk about it. Let's go back to our Sublime text. We are here. I'll keep this use case here. It's fine. It's good to talk about run length encoding in general. I'll come back to this question 7 here. This is lead code 1313. And this is the link. The function that you have to complete, let's talk about this. And even before that, let me take the understanding of the problem statement. This is the understanding. And now coming the function that you have to complete is this one. There you go. You have to return an array. This is important. So if you have to return an array, you have to create an extra array and decompress our array list. It's taking array as input. Okay. Cool, guys. We talked about input, output, explanation. Example 2 looks good. Okay. Let me give you the lead code link in the chat real quick. There you go. And the function that you have to complete. Feel free to code in any language of your choice and directly submit it on the lead code and share the submission link with me. Again, anything required from my end for understanding this question better, anything which is not clear on the requirements, please let me know. All good? Okay. If everything is good, you guys know the drill. Directly solve it on the lead code, share the submission link with me. Do not message to everyone, change your message directly to me. Okay. Your time starts now. Once you guys are done and good to discuss, let me know. We can start with the discussion. Please change your message directly to me. Cool. Everybody's good. Let's start the discussion. All right, guys, let me take the solution part here. So this question is not super complicated. Based upon if you understand what the question requirement is, question becomes fairly straightforward to implement. What the question requires is, at even index, if I talk about every pair in the array, at even index, I'm given the frequency, and at odd index, I'm given the value. So if I start with I equal to 0, I plus equal to 2, that is going to be my even values. So my array of I is pointing to frequency. Array of I plus 1 will be pointing to value. All agree with this? All agree with this? Go to the even index. The next value after even would be odd value. So at odd index, I have the values, and at even index, I have the frequency. All I need to do is I need to implement such kind of a logic. Whatever my answer is, dot pushback value. Okay. Basically, I just need to push value, frequency number of times. That's all I need to do. However you want to implement it is up to you, but basically this is what you need. You need to push the value, frequency number of times. Let's quickly go through the code that will make things easier for us. Okay. Coming back to it, let's come back here. Let's go through it. What do we have here? We define this decompress early function that we have to complete. We start with our size equal to 0. Okay, one thing here. Do we note the size of the values that we are going to have, or the size of the array that I need to create? We don't know. Initially, we don't know, but can we calculate it? Can we calculate the size of the array that we'll do? Yes, we can definitely calculate. How will we calculate? See, you just need to the sum of the frequency. Whatever the sum of the frequency, that will be the size of the array. Yes or no? That's what I'm doing. So I initialize the size equal to 0. What I'm doing here is I go to the even indices where I'm talking about the frequency. I calculate the size of the frequency, and that is going to be size of my final array. Everybody clear with this? The extra array that I need to create, the size is just the sum of all the frequencies. That's it. Okay. Moving on to next. Once we define the sum, what we need to do? I just index equal to 0, I equal to 0 less than I plus 2. I'm just going to all the frequency values. Inside that, j equal to 0, j less than nums of I. I am checking result of index plus plus equal to nums of I plus 1. So I'm pushing all the values in array frequency number of times. This is the frequency, and I'm just putting the values here. Okay. Have a look at this code. Fairly straightforward code. Have a look at this code. Let me know any doubts. Come on, guys, be quick. Code / approach is clear to all. Just go to that frequency comma value pair. For each value of frequency, put the values. That's all you need. Now, if you look at the time and space complexity, if I talk about this portion of the code for the first loop, it's big of n by 2 because I'm traveling half of the array technically. This is a nested loop. Line number 17 is big of n by 2. Line number 19, where I'm going equal to j equal to 0, j less than nums of I. That is going to be whatever the maximum value in the frequency. So what's my overall complexity? Big of n by 2 into maximum of frequency. Space complexity means big of 1. Why I'm talking about space big of 1? Because this function wants me to return an array. That's the array that I've created. Okay. So if I compile this, looks good. If I submit this, pass all test cases. Time complexity, as I told, big of n by 2 into maximum of frequency. If I talk about space complexity, that's big of 1. Okay. All right. Let's take this. Let's go back here. There you go. All right, guys. Any doubts, any questions, anything which is not clear, please let me know. If everything is good, then we can move to next question. Okay. Can we reduce it to big of n by 2, or can we reduce to big of n? To reduce to big of n, yes and no, because even if you go to reduce to big of n, all you need to do is you need to run the times of iteration. So you have to go to the value or frequency value, and you have to run it till frequency minus minus till frequency becomes 0 also. So this is also not big of n square kind of approach. All you are doing is you're going through all the frequency value and you're just implementing whatever the maximum frequency. So either way you do it, it will never be exactly big of n. Okay, it will go through whatever frequency number of times that you have to go through. Okay. All right, guys. Everything else? Anything else? Anybody has questions? If not, then we can move on to next question now. All good? Cool. This was question number 7, right? Let's move on to question number 8. Was it question 7? Yes, decompress RLE. Move to question number 8 real quick. Maximum frequency and time complexity means, see, maximum frequency and time complexity, what moment? Inside loop, it will also run n by 2. Yeah, this is n by 2, this is maximum frequency. That's what I'm saying. J equal to 0, starting with j less than nums of I. So how do you define the complexity of nums of I? Whatever the maximum value is nums of I, that's many times this code will run. So let's say one frequency value 2, one frequency value is 5, right? So if you have to define the complexity, you take the worst case. So worst case will be whatever the maximum time it will run. That's why maximum frequency. Okay. All right. Question number 8 is important. The next question that we are going to start now. And we have time, we can finish this and another question. I'll type this as very important. It's one of the very popular problems, and that's what we are going to discuss, a new algorithm. This is technically based upon sliding window. This algorithm name is different, but this is technically based upon sliding window. This is lead code 53. Name of the question is maximum subarray. Okay. Let's talk about the problem statement, then we'll discuss about it. Okay. A really good problem statement. If you look at the stats speak for itself. This question has 9.3 million submission, which is a huge amount of submission, with 4.8 million accepted only, which is 50%, almost 50%. And if you look at the number of likes, 35.5 thousand like. And if I look about the companies which have asked this question, you can see it's a long list of companies which have asked this question quite frequent number of times. That shows the importance of this question. That's why I tagged this as very important. All right, what's the question? Just two lines of problem statement here, but this can have variations, multiple variations. You're given integer array nums, find the subarray with largest sum, return its sum. So if I hover over subarray, they've said subarray is a contiguous non-empty sequence of elements. The word non-empty is important here. A subarray is a contiguous non-empty sequence of elements within an array. So you're given an array. We already talked about subarray, so I don't need to go through what exactly subarray means. We have talked about in the question of prefix sum. I talked about subarrays versus subsequence versus subset. I hope all of you guys remember that. I very clearly and distinctively covered subarray, subsequence, subset. We also talked about the code. How do you calculate all the subarrays? How do you print it? How do you calculate it? Okay. Coming back to this, what this question is saying is, in my entire array, find the subarray with the largest sum, return its sum. You don't need to print the subarray, you just need to print the sum. So let's take an example. I'm given this value, -2, 1, -3, 4, -1, 2, 1, -5, 4. In that, the maximum subarray that I have found is, it is actually with the sum 6. And that value is 4 -1, 2. And if you take that subarray, sum becomes 6. If you try to take any other subarray smaller than it or greater than it, output will become less than 6. Nums equal to 1, there's only one value, output becomes 1. 5, 4, -1, 7, 8. In that case, you have to take the entire value, the output will become 23. Length goes up to 10 to the power 5 and values go up to 10 to the power 4. If length goes up to 10 to the power 5, can I submit big of n square? Come on guys, quick in the chat. The answer is no, you cannot. And if you try to submit big of n square, that will give you time limit exceed. Okay. Values are -10,000 to +10,000, which is fine. If you figured out big of n solution, try coding divide and conquer, which is fine, no issues. Okay. This question is very useful because the algorithm that we're going to talk about in some time, that's called the Cadence algorithm. And that algorithm is very popular. It's technically just a sliding window, but that algorithm was developed by somebody. That's why the algorithm is named after him. Okay. But this question is very important and it has been asked in many companies in many forms. So that's why I said this has many variations. So I'll talk about a couple of variations, but let's come up to a conclusion for this solution first. Example is here, example 2, example 3. All of this is good. I'll cancel this. This is fine. Let's take this. Okay. Now this looks good. If I talk about the function that you have to complete, this is the function that you have to complete. As it consists of subarray, I thought it's a prefix sum. No, subarray is nothing to do. Okay, understand one thing. Prefix sum is an algorithm. Okay. Prefix sum, running sum, cumulative sum, whatever you call it, it's an algorithm. Subarray is just portion of an array. Subarray, subsequent, subset. Doesn't mean that all subarray question will be solved by prefix sum. Okay. There can be 1,000 algorithms that you can implement on a subarray. Similarly, so think of subarray as just a small portion of array. So arrays questions do not necessarily need to be solved by prefix sum. Same logic. Okay. All right, guys. Now coming back to it. Any doubt in the problem statement? Anything which is not clear? Let me know. Any doubt in the problem statement? Anything which is not clear? Please let me know. If everything is clear, please type clear in the chat. You're given an array. You need to find the subarray with the largest term. Print the sum. You don't need to print the subarray. Okay. That's, if in a very simple term, that's what the problem statement is. However, it's a very good problem statement if you start solving it, considering if you try to optimize your solution. So I want you guys to take your due time. I don't want to rush it into any other problem statement, because pretty much no other problem statement as of now is as important as this one for the interview perspective. Okay. Or in general, in a problem solving perspective. So spend your time on it, try to come up with solutions, then try to optimize it. First come up with a working solution, even if you're getting TLE, completely fine, then try to optimize it. Okay. So let me provide you the lead code link, question number 8, and the function that you have to complete. Feel free to code in any language of your choice. Once you guys are done, please share the submission link with me. Do not message to everyone, change your message directly to me. That being said, your time starts now. Okay, cool. Let's discuss, because we have to discuss multiple things as part of this question and variation as well. Okay. But first thing first, let's start with one question here, like a test case. If it is -2, -1, -3, if the input is this, can you guys tell me what is the output for this question? Okay. Maximum subarray sum is the question. Okay. I'm getting conflicting answers. Anybody else? Let's do one thing. Let's do one thing. Let's print out all the subarrays here. Okay. Let's print all the subarrays here. I'll start with -2, then -2, -1, -2, -1, -3. Okay. Then -1, -1, -3. Then what else? -3. Okay. We'll write the sum as well. So -2 sum becomes -2, -2 -1 sum becomes -3. This becomes -6. This is -1. This is -4. This is -3. What is the maximum sum here? Anybody? What is the maximum sum here? The correct answer is -1. Provided one thing that we have not considered, we have not considered the empty subarray here. Yes or no? Quickly in the chat. If I talk about containing at least one element, then this definition holds completely correct. But if I talk about does not containing at least one element, because by default, this is also a subarray. And if this is a subarray, the sum is 0. And if this is 0, the maximum sum will become 0. If empty subarray is allowed. This statement is clear to all, yes or no? If the problem statement said that the subarray should contain at least one element, in that case, my maximum sum will be -1 for this test case. But by default, empty subarrays are also allowed. So if by default, there's nothing specifically mentioned about this, if empty subarray is also allowed, then the output will become 0. Is this statement crystal clear to everyone? Quick in the chat, guys. Okay. Now coming back to our problem statement has very clearly mentioned that subarray should contain at least one element. So we will stick to this case. However, we'll talk about the code, both of them. There's hardly one line of code change which will make the difference, but it's important to clarify what the requirement are. Whether do we allow the empty subarray or we do not allow the empty subarray, because that will change my output accordingly. Okay. All right. If this part is clear, now let's talk about the solution. In terms of approach also, let me mention it here. If empty subarray allowed, then that empty subarray sum will become 0. Okay. Now coming to the solutions part. Solutions, more or less, there are two solutions which we're going to talk about. One is a brute force solution, and second is going to be cadence algorithm, which is nothing, which is just a sliding window. What are those solutions? Let's go one by one. The brute force solution, which I see a lot of people writing code, is the question is asking you find a subarray, or not even just find the subarray, find the subarray with maximum sum. So you need to find the maximum sum, or basically you just have to check a subarray which gives you the maximum sum. So the most naive way or the most brute force way could be, I can find all the subarrays, I can take sum of all the subarrays, and then I can compare whichever is the maximum. All agree? I can take all subarrays, I can take sum of all the subarrays, then I can print out whichever is the maximum one. So I can find sum of all subarrays, and then I can find the maximum. Time complexity big of n square, space comp big of 1. This is fine considering with the brute force approach. The only problem here is if you look at the constraint are going up to 10 to the power 5. So if you try to submit something called n square here, you will get into TLE. And that's the biggest reason this question has so many less accepted solution, even though a lot of tried solutions. 9 million solution and 50% acceptance, that speaks for it. Okay. So what is the optimized solution? Let's talk about the optimized solution. Optimized solution, which is cadence algorithm. Let's go in details of what exactly is cadence algorithm, that we'll talk about it. Cadence algorithm. Cadence algorithm is nothing, it is built upon sliding window. What is that? It just starts with, you start traversing the array. For each element, we keep two variables. Each element that we traversed, we keep two variables. One is called current sum. One is called overall sum. Okay, there is current sum and there is overall sum. And third, you find max of all sum. Okay, max of all sum is pretty much the overall sum. Only one edge case is that you have to take care of. Basically, max of overall sum, which is your overall sum. Only edge case is if your current sum becomes negative, then you set your current sum to 0. That's the only edge case. Okay, let's talk about it one by one. So first thing first, the approach is you start traversing the array. For each element, you keep current sum and overall sum. And whatever the maximum of overall sum, that is in the overall sum. The only edge case is whenever current sum becomes negative, you set the current sum to be 0. Okay, let's go to the code part and then we'll be able to understand it better. We are back in the screen of maximum subarray sum. Let's come back to here. What are we doing here exactly? I take my n equal to nums.length. I define the maximum value to be integer dot main value, current sum equal to 0. Now understand the word. I have taken two sum. One is current sum, one is the max sum, of which I'm calling as overall sum. I traverse the array I equal to 0, I less than n, I plus plus. Current sum means whenever new element become, that will become the current sum. Maximum sum is the overall sum. So I'll keep a math.max, whatever the maximum value of current sum or versus overall sum, I assign that to overall sum. One edge case, if current sum becomes negative, I set the current sum equal to 0 and then I return the max sum. Look at this portion of the code and let me know anybody has any doubt, any questions. Look at this portion of the code. Let me know anybody has any doubts, any questions. If it is clear, please type clear in the chat. Okay, cool. How many of you want a dry run for this code? I'll come to it. I'll come to it. That is only to handle the negative cases, by the way. Before I even go there. Okay, how many of you need the dry run first? I would recommend to go for a dry run because this is an important question, but I leave it up to you. I'm happy to do a dry run. Cool. Let's go with the dry run. Second thing, let me ask you a question. Do you think this code will work fine with the negative values? Do you think this code will work fine with the negative values? Okay. So you are saying that if I pass negative value, this code will give incorrect answers. If I understand the no properly. Okay. Anybody else? Okay. I think it will work. Cool. Let's see. If I compile it, I do have negative values. It's working completely fine. I'm getting the answer and it will work. See, the whole point of adding this condition was to take care of the negative values. But anyways, let's go through it. Yeah, let's go through the explanation. I think let's go through the dry run part. That will make things much clearer. Let me take this guy only that we discussed, -2, -3, -1. And let's try to come up with an answer. Let's see what is happening at what stage. Okay. All right, let's go through the code step by step. That will make us things clear for us. Okay. The input array is -2, -3, -1. Let me take this here. Here. Coming up to first part, I become 0. The moment I become 0, my current sum, which is initially 0, will become nums of I. So what is the value of current sum now? Quickly in the chat. What's the value of current sum now? For I equal to 0. Come on, guys, be quick. Current sum will become -2. All agree? Cool. Next, max sum. Max sum would be what? Maximum would be math.maximum, current sum and maximum sum. What is the value of maximum sum? Maximum value of maximum sum is -2 raised to the power 31. So you have to pick the maximum of -2 raised to the power 31 versus -2. Which value is greater, -2 raised to the power 31 or -2? Obviously, -2 is greater. So max value will become -2. Is my current sum negative? Yes, my current sum is negative. So we set the current sum equal to 0. We set the current sum equal to 0. Looks good. After the first iteration at I equal to 0, my current sum was initially -2, which has now become 0. My maximum sum is -2. Anybody, any questions? Let me know. After the first iteration. If it's clear, just type clear in the chat. We can move to next. Okay, let's go to I equal to 1. Once we go to I equal to 1, current sum will become current sum plus equal to nums of I. So, okay, so now what will be the value of current sum? Quickly in the chat. Guys, focus. Focus, guys, focus. Nope. Understand what we did at the last part. At the last part, we set the current sum equal to 0. Yes or no? At the last part, we set the current sum equal to 0. So what will happen now? Now my current sum will become -3. Okay. It won't be -5. Those people who are mentioning -5, look again. At the last part, we set the current sum equal to 0. So when I start with I equal to 1, my current sum will become minus 3. So my current sum is currently minus 3. Okay. And if I talk about max sum now, what will happen with the max sum? Math.max, it will compare the current sum, which is minus 3. It will compare the max sum. Max sum was what? Max sum was minus 2. So you compare between that. So max sum remains minus 2. Okay. And is my current sum negative? Yes, my current sum is negative. So current sum will be set again as 0. After second iteration, current sum becomes 0. Max sum becomes minus 2. Everybody crystal clear with that? Okay. Now we move to the last iteration. We put the current sum. In that current sum, that will become minus 1, I equal to 2. The moment current sum becomes minus 1, why minus 1? Because it was set as 0. So what you do is 0 plus minus 1. That's why it becomes minus 1. What about the max sum? Now the max sum will try to compare the maximum value of minus 1 comma minus 2. So which one is bigger? Minus 1 is bigger. You got the output minus 1. Is my current sum negative? My current sum is negative. It will set to 0. After the third iteration, my maximum sum become minus 1. My current sum will become 0. Yes or no? It does. So maximum sum becomes minus 1, and that's why your output becomes minus 1. Everybody crystal clear with the code now. All I'm doing is understand this. It's a very simple sliding window. Very simple sliding window. It's just that it was developed by a mathematician. So it was named after that mathematician that we call as Cadence algorithm. Okay. But it's just a sliding window. What are we doing in that sliding window? We are talking about the current sum, basically the current value, because anyways, we are defining the current sum becomes 0 for a negative value. If it is not contributing it, just set it to 0. If it is contributing, keep on increasing. Whatever is the current sum I've got of the subarray versus the overall sum, and whichever is giving me the maximum value, I'm keeping a check on it. The whole point of if condition here is to take care of the negative conditions or the negative values. Okay. Now let me know. I'll come to that. Now let me know anybody has any questions about the approach. Then I'll talk about follow-up that I have to talk about. Okay. Before that, anybody has any questions about this before I go to repetitions? Okay, all clear? Cool. Somebody asked me to repeat for I equal to 0, I equal to 1. I'll quickly repeat it because I've already explained in detail. See, I equal to 0, current sum value is initially 0. So you put current sum plus equal to nums of I. So I equal to 0, it will be minus 2. So current sum becomes minus 2. Maximum sum, you will be comparing with maximum of minus 2 and minus 2 raised to the power 31. So between minus 2 and minus 2 raised to the power 31, the higher value is minus 2. That's why maximum sum become minus 2. Then you reset the current sum equal to 0. Then you go to I equal to 1. Same case, current sum becomes minus 3. You compare between minus 3 and minus 2. Output become minus 2 here for max sum. And then you reset the value to 0. That was for I equal to 0 and I equal to 1. Okay. Hope that answers your question. Now, one question, which is a good question somebody asked is, how do we come up with this approach, or how do we even think of this approach? See, to be very honest, this approach is not too difficult to think about. Over a period of time, you will get to know how to come up with this approach once you solve enough number of questions. But if I talk about very bare basics or connecting the dot backwards, how we can even think of this approach? A simple way is that subarray definition is what? Subarray definition is consecutive values. Agree? If I have to just break down into bits and pieces or the first principle, subarray definition is taking the sum of the consecutive values. So I can divide the consecutive values into two categories. If my current value is actually the overall maximum value or it is not, that gives me two ways. One variable for current sum, one variable for maximum sum or overall sum. That's how I've implemented this code. Okay. Cool, guys. If everything is crystal clear, just give me clear in the chat, then I'll ask a follow-up question. All of you guys, if everybody is crystal clear. Okay. Now here comes the follow-up question. If the tricks to set current sum 0, yeah, that's for negative values. Yeah. If I want this question or I want this code to work for even the empty subarray case, which line number I need to change? what exactly I need to change. We'll talk about that variation. Let's talk about this one first. If I want this to work for empty subarray case also, for example, for this case, the output will be 0. Which line number, what change do I need to make in this code? Quickly in the chat. If maxsum is less than 0, return 0. Do I need to change the maximum value? I is less than equal to n. I is less than equal to n. Is that correct change? If you do I less than equal to n, this will give you overflow. Okay, so that is not a correct change. The correct change is this line here. Whatever you initialize with integer dot min value, if you initialize with 0, it will work. Okay. So if empty subarray is allowed, I'm going to set this guy to be 0. Okay. And in that case, what is going to happen? One moment. In that case, what is going to happen? For -2, -3, -1, output will become 0 here. Actually, let's take this guy here. Cool. And if last maximum is negative, then return 0. What about this one? You can do that also, but that's not required because technically you are adding a condition to compare with the maximum. If you take care during the initialization itself, that will work. Why do you need to initialize with the integer dot main value? Why didn't you initialize with the 0 in the first case? We didn't initialize with the 0 in the first case because we don't want the empty subarrays to be included. So, I mean, both will give you the answer, but if you talk about approach-wise and strategy-wise, this makes more sense. Okay. All right, guys, let me add some notes here which we discussed. So that will become easier. This looks good. And I'll add one more thing here. This one. Not in the chat. One more. Okay, good. Cool. Okay, now let me answer your question. Empty subarray means we are not considering the negative values. No. Empty subarray means, see, by default, when you list down all the subarray, empty subarray is also valid subarray. Understand this. By default, when you say all subarrays, empty subarray is also a subarray. But in the question, if you look at it, it says, when I highlight about the subarray, a subarray is a contiguous non-empty sequence. They have highlighted the word non-empty, means they are not considering the empty subarray itself. Okay. So we have to ignore that case. That's why. Okay. All right, guys, if everything is good, what is the time and space complexity? Quickly in the chat. What is the time and space complexity? Correct. Time complexity here is big of n. Max function works in big of 1 time. So this is completely big of n. Space count is big of 1. O(n) time, O(n) space. This is the most optimal solution. Let's compile it. Let's submit. O(n) time, O(n) space will defeat all the summations. This is O(n) and this one has to be O(n) as we expected. Okay. All right, guys, this was interesting algorithm to solve. We have discussed about that. Let's close this one now. One moment. Time complexity becomes big of n, space complexity becomes big of n. Okay. Right now, if I know where the question is, topic-wise is easier to think, but randomly pick difficult. All of that will solve in due time. You are still on the very first data structure that we're talking about. Give it due time. Okay. As I said, just stick to, we will be solving around 350 to 370 questions overall, including in-class versus in-class and the assignment as well. And the lead code top 150, lead code top 75 will be doing that. Okay. Yeah, coming to that part only. To return the corresponding part, what we would need is we would need to keep a map. In that map, we can keep the index. You can just need to basically store the index where you're calculating the maximum subarray part. So starting the beginning index and the ending index, you need to do that. So keep a map, find the beginning and ending index, and print the values between that beginning index and ending index. That's all you need. Okay. All right, guys. This was a really good question to solve for. We are right on time. So let's quickly go through what we discussed in today's session. We did solve some couple of really good questions. So I'll mark this guy as done. I'll mark this guy as done. We are done with all the important questions in terms of algorithms. Product of X itself is a good question. We can talk about it. But apart from that, we are pretty much done with all the important question. Maximum subarray sum was a very important question. Let me highlight here also. This is also done. Okay. Then we can move to the next data structure. But before that, let's have a quick revision what you've done as part of today's session. We solved a real lot of good questions, starting with question number 5, lead code 324, wiggle sort 2. Okay. Wiggle sort 2, we talked about the solution based upon sorting, how we can implement the sorting. We divided it into larger and smaller values in terms of even and odd indices. So what do I need to do is odd indices, I need to put the larger value after sorting, even indices, I need to put the smaller value. Time complexity and log n, space complexity big of n. I'm coming to that. Question number 6, lead code 1431, which is the kids with greatest number of candies. It's directly straightforward question, nothing much to implement here. The approach is find the maximum. If array I plus extra candies become greater than equal to maximum, return true, otherwise return false. Time comes to big of n, space big of n. Run length encoding. I first talked about a bit of the algorithm and its use cases. Then we solved question number 7, which is lead code 1313, decompress run length encoding. So it's a good question in terms of understanding frequency and value pair. What I need to do is I already get the compressed value. I just need to decompress it. Okay. So I come back to the code part. What we're doing is we're decompressing it. Time const big of n by 2, space const big of n by 2 into max of frequency, space const big of 1. And finally, we solve question number 8, which is lead code 53, maximum subarray. It's a really good question. First, we talked about the difference between empty subarrays allowed versus non-empty subarrays allowed. Then we talked about in terms of solution, brute force, finding sum of all subarrays, finding maximum, which will definitely lead you to dually based upon the given constant. Optimized solution, we talked about cut-ins, which is built upon sliding window. We talked about dry run, we run the code, time and space, complexity, passed all test cases. Okay. All right, guys. Now to your questions. Number 1, what is the next topic? The next topic is after doing maybe 1 or 2 more questions. Otherwise, we can directly start with the next question. The next topic is going to be linked list. Okay. Uh, to the next part, the first time I'm not able to do it. Later, when should I solution felt it easy? How should I do? How to get the idea? See, at this moment, I would say give it a day or 2 at max, not more than that. If you're not able to solve it in a day or 2, you can feel free to go and refer to the solution. And when you refer to the solution, my piece of advice is look at the lead code editorial section, because editorial section is really good. They list down all the important solutions, starting with the brute force, then coming to the optimized, then coming to the most optimized. They have a lot of video content. They have a lot of diagrams, how they come up with the brute force to most optimized. You want to check in the submissions of other people, feel free to do that. Nothing is wrong in that. Whatever happens, whatever helps you understand the code better, feel free to do and implement that. But lead code editorial section is really good one. Editor is paid one. I don't know if it is paid one because I have the premium, so I'm not 100% sure. But the way they define in the editorial, they start in a very good way that is actually expected in an interview. They start with brute force, then they try to optimize, then they come to most optimize. I'm not 100% sure whether it is paid one or not because I already have the premium, so I'm not sure about that. Okay, cool. So if it is paid one, then you can refer to the submissions. Like you can see the submissions of other people, right? Yeah, we'll cover stack. Don't worry about it. Last session not explained very well. One moment, guys, one moment. Editorial, okay, that is discussed. There was one thing which I missed. I'm solving question but not able to gain confidence. It will come in due time, guys. You have just started with your course. Let's give it some due time. Stack and also last session. I did not start with stack yet. What was the last session that you are referring to? As per my understanding, I did not start the stacks and queues when you were on leave. That's the first question I asked yesterday. When I was on leave, I think there were no classes, right? Okay, someone takes stack session. I'm not aware of it because as per my understanding, which I got from you guys yesterday, during my leave, there was no sessions conducted. That's my understanding, but okay. Anyways, I'll cover the stack part. Okay. I'm not sure how many can log in, but I'm pretty sure like 5 to 10 people should be able to log in. Okay, only one class. Anyways, I'll cover the stack. That should be fine, but that will cover after linked list. Okay. We'll cover the sliding window. Don't worry about it. I've designed the course in such a way that everything will come in due time. Okay. So I do not, I mean, I've been teaching for more than 8 years now. So I've specifically designed it how it will be kept at a certain place. So don't worry about it. We'll cover everything in the data structures algorithm. So you don't need to worry about it. I've solved 4.5 out of 5 area assignment. I believe some questions are good, thought-provoking. Question based on binary search, prefix some are missing. Okay, we'll discuss that. I mean, these are not the list of end list of questions. So we'll talk about more advanced question as well. For example, the current question of wiggle sort, that is also based upon implementing binary search based upon quick sort. So we have a lot more questions coming up. So don't worry about these assignment questions. That's a good question that's curated by me, but you will have regularly tests conducted. You will find more advanced level of questions. As I said, you are still in the beginning of your DSA syllabus. Once we move on, we'll move to the more advanced question. Okay. Solve the assignment will be covering all patterns, pretty much the same thing. Yes, it will be covering over a period of time. The category of questions or the degree of hardness of the questions will increase. Okay. Cool. That's fine. All right, guys. Anything else? If not, then we can wrap up this session here for today and we'll connect in the next week. Okay. All right, guys, thanks for joining in. Let's catch up in the next week and we'll continue from there. Thanks for joining in. Have a good one.